Good afternoon. My name is Leonard Chinedu. I want to do a brief walkthrough of this website. So, this website actually looks at the OWASP 2021 top 10 vulnerabilities and some recommended countermeasures and some web application penetration testing tools that could be used to explore them. So first, we'll start with the search field. And what is this search field? It's saying KJV Bible search. But as we all know, search fields are usually prone to cross-site scripting or cross-site request forgery. So for instance, if I type script alert SSS, now in a vulnerable search field, this would throw up an alert box. But here we demonstrated that it could be sanitized such that it will just display for us not found with the content. So major websites do this to just tell you that what you search for, they can just sanitize this without embedding it to the HTML. This is actually not the case when we go to a vulnerable site. If we go to a page that is prone to cross-site scripting and we try just the same thing, you'll find out that it will throw up an alert box to tell you that this page is not secure. It actually throws up an alert box, meaning that it executed that for us. So if we quickly go back to the secure page we were working with, now this is a secure page. Next is, what if I type something reasonable? Okay, if you type something reasonable on this search field, it will actually allow it to operate and get you answers. Maybe the search field is mostly for biblical results, tells you where things are, how many times they are, but that's for another day. So what we are majorly focusing on is the vulnerability aspect. Now, it's possible for us to validate this form such that it doesn't submit at all if you type a malicious content. But after research from Google and some other search engines, you realize that they don't go to that extreme. They allow the user to type in some bad characters, but then it's their job to sanitize. But that's achievable. We've done it and tested it. Now, the next thing we're going to be looking at is the sign-up form. Now, there's a sign-up form here. And why did we make it big? Is so that we can test some things. So if I go to this sign-up form and I'm typing a name and I make a mistake, it will quickly tell you that only white space is allowed and numbers and letters in a name. So you don't make such kind of a mistake and the form will never submit. If you are typing a phone number, for instance, and you get the phone number right, there's no error. But you try to start putting in malicious characters, it will tell you no, that is not accepted, and this form will never submit. The same thing goes with email. If you type something that is not a correct email, it will tell you invalid email format, means it has not seen the @ symbol, it has not seen the correct structure. But if you try to sanitize it, if you try to do it well yourself, you find out that that error message disappears. Now you go to the password and let's say you start typing a password. It tells you the requirement for password. One, the password must contain at least 12 characters with 2 uppercase, 3 lowercase, and 2 numbers and 1 special character. Why are we doing this? Now there are some recommendations by NIST about password length and complexity. So we find out that if for this particular site you meet up with the complexity, it will eventually remove that error message and only tells you that password does not match. So if we type in the same thing again, it will now remove all the error messages and allow you to create an account. But we have already created an account to save time. So we remove this and then we go straight to the login form. Now, the login form is here. Now, I want to demonstrate some SQL injection that are being used by some people to bypass authentication. Now, this is the secure login form and such things will not work. So if you do something like this, for instance, and you try to submit it, it will not accept at all. Why? This thing here is not a valid email, so it will not submit at all, no matter how you click the login. Well, let's say I go to a page where there is broken access control and I look at the login form and I try the same thing again and I say, let me just comment off the password and try to log in. You see the page is loading, and before you know it, it logs the person in to a vulnerable index page. So it takes you into this place because you are able to bypass the password. So if we go back again and try a more severe case, you can try or 1 equals 1 and then you put this and then you just put any password. It doesn't matter what you put, and you click on login. You find out that it will still log this person in because this is an SQL injection. It's malicious. It takes you into the account of Joseph. Joseph could be the first person in the database, and that kind of attack will allow you to access the first account in the database. This was permitted deliberately, but we have shown that in the secure page like this login.php, always take note, the secure page is the login.php, that attack is not possible. So you click it from now till tomorrow, it will not submit. So what else do we now do in a very secure case? Now, another thing we did was to say, for instance, if I'm using this account and I make 5 failed attempts, you should block this account and send an email to the admin, and then this person can only reopen the account if he goes through forgot password and receives an OTP. It's only in that case that this account can be unblocked. So let's quickly try this account 5 times. I tried some wrong password 1 and then said doesn't match. I try it again for another wrong password 2, it still doesn't match. I try it again with another wrong password 3, it still says doesn't match. I try again for another wrong password 4, it doesn't match. I try again. Assuming an attacker is trying to brute force from a machine or even manually, you find out it now displays a message, 5 incorrect matches exceeded, please click on forgot password for an OTP, and then it sends an email immediately. If we check the account we used for email, okay, you see here brute force alert. So it shows you, it appears an intruder is making an attempt and is using a particular, it gives us the particular username, tells us the particular time that the person made the 5th failed login attempt. So that's by the way. So we go back. Now we want to demonstrate a 2-factor authentication for a users that wants to go beyond even 5 incorrect matches to 2-factor authentication. So we've created an account for that, and let's say we use this account. This account has 2-factor authentication. So when I try to enter the correct username and password and I log in, it will first of all validate the password and then come to this page and tells you a one-time password has been sent to this email and to an SMS to this phone number. Now, if I open this image, this is how the SMS will come into a phone, like Clear Portals, for you to log into www.ordinarybible.com, use this OTP. Okay, that's by the way. But let's check the most recent email that was sent. Okay, 2-factor authentication email. Right now, this OTP was just sent, and we can copy it and use it to complete the authentication. So at the same time, it was sent to the phone. So we can use the one on the phone to complete the authentication. Some bank applications do like that. They send you both your email and to your phone. So now this is an admin page. And in this admin page, we've created some things. Now, we did login and monitoring. Now, what's login and monitoring? Means an admin can go to the log details and then check. Now, if we scroll down here, you see that all those attempts you've been making with this username were actually recorded as login failed, login failed, login failed, login failed. And then the last attempt we made, login successful. So it keeps track of all the history of login and logout. So if we log out now, like in some cases before, it will tell you that this was logged out. Now, if somebody used a machine like OWASP to perform an attack, it will still keep track of some of those attacks and tell you somebody is using a machine to attack your login page. So that is for the authentication log. Now, that falls under the OWASP login and monitoring failures. And now we look at sensitive information. When we look at cryptographic failures, which is presently the second most vulnerable issue in the OWASP top 10, and we look at card encryptions. Now, assuming I have some cards which I have inserted into the database, the question now is, how were they saved? Now, this is the retrieve format. You can see I clicked on view decrypted cards. This is the plain text. But if we are to save it in the database, we are to encrypt them. Now, if I go to view encrypted, it will first of all use AES256 GCM to encrypt them, and then it will display the base 64 encoding of that particular card details. And then this other link is just for us to add more cards. If we add a new one, it will still encrypt it before saving. So if we go to the database, we'll only be seeing this ciphertext. That is to avoid some offline dictionary attack and brute force attack in which your database could be retrieved. And by GDPR compliance, if your database is retrieved and you didn't save sensitive data properly, the fault is yours, not the attacker's fault. So now, another place we should be looking at is the recovery of credentials. So assuming I log out now, for instance, someone has tried to log in and he forgot his password. Now, we also indicated here that in such a case, the person will also receive an OTP before he will be able to reset the account. We've already demonstrated how OTP is being sent to email and how we use that was on two-factor authentication, but the same procedure is used for password recovery. And then, why did we demonstrate this? If you go to the vulnerable page, you find out that some websites do something like this: forgot password, and you click, and it starts asking you your username, and then it starts asking you security question, and then it starts asking you security answer. Now, we can use this, and we've used this for some accounts. But then when you do something like this, somebody can brute force it with a popular name. You can say choose name and you choose your brother's middle name. Somebody can do some reconnaissance, go to your social media and find out some names in your family and use it and try. Some may even get word list from GitHub and use word list of popular names and breach it. Now, we've tried this with Hydra and it's in the detailed documentation, but we don't have time in this demonstration to show that. Okay, one more thing we'll look at is cross-site request forgery. Now, we'll demonstrate it with the vulnerable page, and then we'll now demonstrate that it's not possible on the secure page. Now, assuming this is a vulnerable page and somebody logs in with an authentic username and password. Okay. Shit. Okay. So somebody logs in correctly into the system, but then just like some people make these mistakes in cyber cafes and public places, you leave your account open and somebody comes and makes something like this. Maybe your Facebook account is just there staring at the person. Now, if that site has a weakness such that it doesn't check the old password properly before migrating to a new password, it's possible for an attacker to use a script like this. So if I copy this script and I put it, now notice that on this script there is password Q3A12, password Q3A12 repeated, but there is no old password on that URL. So if I copy it now and I put that script on this field, yes, means I want this password to change, the person's password to change to this, and I press search, it will actually run that script to a vulnerable page and then change it and tell me not found. But something has been done. Means if we log out now and try logging in with that new username and password, it will actually allow us. So if I press Q3A12, that's what we used. Let me copy it properly. Okay, I think I use small letter Q. Oh shit. Okay, so if I paste that here, how do I do it? Okay. Yes, if I paste that password here and I try to log in with that account, you find out that it logs me in because that script was able to change the password. Now, why did we demonstrate this? If you go to the correct login page and let's say you still log into this account and you put the current password of this account and you are able to log in. Now, it's possible and it's secure in this case that if we copy this script again and we try, for instance, copy it again and try to paste it in this search field we are seeing here. Now, this page looks similar to the other one, but this one is the real index.php. The other one was indexv.php. So if we copy this and put here, and we'll try clicking on this search button, the search button will never submit. Why? Because it's seeing some special characters. And how did we do this? If I go to the code, you see a function in JavaScript, valid search. It gives a search format with a regular expression that says it must abide by words and numbers and some punctuation marks. So that is in a very extreme case now that we are trying to say we don't even want to receive something and then start sanitizing. We just want to reject some of these special characters in our search field. So it doesn't submit at all. So there's no way you can do that on a secure site. That's not to say that this search field is not working. If you type something like, okay, let's type something like love on that search field and we just submit. You see the search field has triggered because there's no special character in that word love. So it will take you to places where love is found in the Bible. That's for another day. So we log out. And then I wanted to just demonstrate the difference between this login form here and the login form that you find on the vulnerable. Now, we use Hydra to demonstrate that quickly. Let's say I go to my Kali and I log in to Kali OS and I come to Kali and I'm seeing a particular username with Gmail and it's telling me that if I go to vulnerable.php, now we already have a text file here containing a password, different password, including the password of this account. Now, note that this place is saying vulnerable.php. Now we want to first try it on the main login. The main login page is login.php. So we can try to run this attack, and you see what it does. It does the attack very fast. One of the things it will do is to send an email to the admin that somebody is brute forcing with this account, but it will not reveal the password because there is limited login attempts. The moment it passes the minimum set, for this site we just set 5. You can even set 3. So it will try to tell you that it wasn't found, whereas the correct password is there, but it doesn't find it. And after this attack, it will send an email to the admin. Now, assuming we run the same attack, but this time around, we run it on vulnerable.php. We run it on vulnerable.php and we'll tell it to search for the correct password for this account. So now you see it has made a hit. On this line is telling us the correct password is this. Now that is because vulnerable password has unlimited failed login attempts. It can run for, even if you pass a file of 1000 passwords, it will allow you, but this particular one will not. Even though the password is there, the moment it meets the minimum, it will simply reject it. And then the next thing it will do, if we check closely on the email, you find out that that Hydra attack just sent a brute force alert again on the administrator's email. Now, one more demonstration we'll do is clickjacking. Assuming we go to clickjacker.io and then we try to see if this site can be clickjacked, and we test. Now it gives us results. It says Firefox can't open this page. Why? Xframe options, set origin, CSP header, frame ancestors. It is safe from clickjacking attack. Now, why did we do this? If I test again, but this time around I use vulnerable.php, we have deliberately commented off the security headers from this particular page, vulnerable.php. Okay, and we test again. You find out that it has put that particular page in an iframe and is telling you missing header, Xframe options, missing anti-framing policies, CSP header. Means that this page does not contain security headers, but we intentionally did that for demonstration purpose. And then one more thing that could also be very malicious. If I go back to the secure page and I log in with an account, let's say I log in with this account, okay, and then we go to maybe the profiles picture and we want to change the profile picture here. Okay, it's telling us to browse a profile picture, and then let's say I want to change it to this, and I upload. It will say wait while it's uploaded. So it uploads that image for us. Fine. But if I go back again and I say I want to change the profile picture to a HTML file and I upload, it says invalid file format, cannot accept a HTML file. Now this is on the secure profiles.php. If I'm supposed to log out from that secure site and then try to do that with the vulnerable side of the page. Now, you find out that if you don't include the security measures, it will even allow you to upload a PHP script in the name of profile picture. So this was the last profile picture that was there. So if I try to change it now, and I say, for instance, I go and put this same HTML file again, and I press, it says file successfully uploaded. Why? Because there's no validation. So an attacker can even upload a script or an executable file into the server that is having high severity and impact. So we'll leave that for another time. Now, lastly, one more thing we'll demonstrate is the use of Bob Suite to intercept a post. After this demonstration, we'll end it here so it doesn't become too long. Right. So, assuming I check the Foxy proxy, Bob is on Bob, and then if I go to the home page, I will see a place. Okay, this is the home page. I'll see a place to post news, post scholarship, post job adverts, post. We try to demonstrate horizontal privilege escalation. Now, for instance, somebody wants to post a scholarship news on this site, and that person is logged in as deslian20@gmail.com. That's the email. So it brings him here. Let's say there was one post he has made before. Maybe he has not approved it for public view. It's still pending there. Okay. But then, assuming you want to make one post, but as an attacker may want to do, let's say we are talking of Commonwealth scholarships, and then let's say the source is a URL from LinkedIn, and maybe someone has a more accurate page. Then let's say you just want to post a little information. But what we want to demonstrate with all this is, for instance, the Bob intercept is there with Foxy proxy, and we go to Bob and we turn intercept on. And the moment we turn intercept on, we try to submit this. When we submit it, you notice it's just loading non-stop. So when we come here now, we see what we typed. Okay, Commonwealth here, and then LinkedIn, and then all that. Now we are interested in the email of the sender. An attacker may intercept a post while it's being delivered. It happens when you're using HTTP or when there is a proxy. Now we can send this to the repeater, and then we go to the repeater. Now on the repeater, we might want to modify this to another user we know. Let's say we know that this is another valid user in the system. deslian@gmail.com. So we've modified it, and then we try to send. So when we send it, we notice a message it will give after being sent. So what we want to show is this. If you on a safe site, now notice here we have updates.php here. Now you try to modify the email to another person and you send, and it will simply tell you unable to create post, sender email does not match with session email because of the alteration. But assuming we use the vulnerable version, and deliberately I create two files. The vulnerable version is ended with V, The secure version doesn't have any V. Now, if I send this request again, and then we check the message that it displays. Okay. So here it says post successfully added, waiting for approval for your public view. So that's the difference between a sanitized and an unsanitized work. Now, what do we mean by that? If the user, the developer building the system does not properly check in the code some of these things, it may result to a horizontal privilege escalation. It could even be worse if it is with an admin account. It becomes a vertical privilege escalation. Thank you.